Hey class, this is Gigi from Core Community College. We're talking about infinite limit. In this problem, we are given the function and its graph. The question is asking, what is the limit as x approaches -3 of f of x? Okay, so from the previous video, we would say, hey, we need to look at the function value as it approaches -3 from the left and from the right. They are both going to the same direction. So therefore, this limit as x goes to -3 of f of x is -infinity. Okay, now because both the left is equal to the right. Okay, similarly, we can say that the limit as x goes to 5 of f of x is positive infinity. Okay, so this one is not too hard to see, right? When we have the graph. Now, what I really want you to do now is to think about this as part of the asymptote. Why are these things your asymptote? And why is the function behaving like such? Okay, so when we are given a graph like this one, we would say, hey, this function, f of x, can be written as x over, and if we did factor this out, we will have x minus 5 square and then x plus 3 square. So we can see that a fraction here is going to have infinite limit, or where the vertical asymptote would be is when the fraction, its denominator, is approaching 0, right? So the question we are now asking is, when is that denominator approaches 0? Okay, so that would be at x equals -3 and x is equal to 5, as we can see on the graph. Now, how do we prove that the limit is -infinity at -3 and the limit is positive infinity at 5 without having to rely on a graph? Right? So before you actually have seen the graph, how do you know that? Okay, so let's go ahead and take a look. We are looking at the limit as x goes to -3 from the left of f of x. And f of x is this function here. So think of a number that is close to -3. So the numerator is approximately -3. We can do a direct substitution there. And we can also do a direct substitution here for the factor x minus 5. So something close to -3. -3 minus 5 is -8. Square that. That would be positive 64. However, this part right here, when x is approaching -3, -3, and we can't really do a direct substitution because we can't have 0 on the denominator, right? And the concept of limit says that x does not necessarily have to be defined at -3 because we are really just going so close to -3 that we're thinking of a number like, say, -4.00000, wait, 4.9, what am I saying? Approaching -3 from the left. We're looking at like -3.00001, for example. Okay, so just a tiny bit bigger than negative 3. Plus 3 is going to be a negative small number. But what are we doing to that? We're going to square that. A small number multiplied by a small number is going to be even smaller. However, the most important part is that when you have a negative number and you square up, you would have a positive number. Times 64 times a really tiny number is still going to be a small number. For example, if you can look at this here, 0, 0, 0, 0, 0, 0, 1 multiplied by 64. Well, you're still going to have 0.0001, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 4, right? That still is a small number. And remember, we're going very close to negative 3, so that the difference is going to be even smaller and smaller. So a tiny number multiplied by a constant is still going to be a tiny number. So we will have then negative divided by positive is positive. 3 divided by a small number is going to be big. For example, 3 divided by 0.0001, right? Now, if you think about this right here, this is 3 divided by 1 over 10,000, right? And then to divide by a fraction, you would keep the first number the same, and then you flip the other number over, so that would be 30,000. You see how constant divided by small is going to be big, right? So that's the concept that we are dealing with here. Okay, now how do we know that, then let's justify, how do we know exactly that the limit as x go to negative 3 is negative infinity? We also need to look at what happened to the function when x is approaching negative 3 from the right. Okay, so approaching negative 3 from the right, the numerator stays roughly negative 3. The first factor stays roughly 64. And the second factor, even though this is going to be a positive small, when we square a positive small, it still is going to be a positive small. So that doesn't change because of the square. So what we end up having is negative 3 over a positive small, which is the same answer as x approaches negative 3 from the left. Now, left and right are the same, so we can now conclude that the limit as x goes to negative 3 from the left of f of x is negative infinity, because left and right are going to the same number. Okay, so that's how you would think about that algebraically if you didn't have a graph. Okay, now the same thing will apply if you were to approach 5 from the left and 5 from the right. And I'm going to leave that for you to justify.